Hi guys, today we're going to learn how to find integrals using U-Substitution. So, when we take the derivatives of composite functions, we use the chain rule, okay? Now, the reverse process is called U-Substitution, okay? Now, let's recall that the chain rule states the given. Y is equal to, let's call it f of u, and u is equal to g of x, then the derivative with respect to x of f of g of x is going to be equal to the derivative of the outer function inside g of x and times the derivative of g of x, okay? What we know is that the function g is whose function is the range of the interval I, and we're going to let f be the function that is continuous on the interval I. If g is differentiable on its domain from the definition of an antiderivative, what we have is that the integral, okay, of f prime of g of x times g prime of x dx is going to be equal to f of g of x plus c. Please note something very important. You have the derivative of the inner function outside, okay? So that's what you have, or in other words, you have f of u plus c, okay? It might be easier to think of this idea in this way. If you have that the integral of f prime of u du is equal to f of u plus c, and that's where the name comes from, u, okay? U-Substitution, okay? So the key to solve any U-Substitution problem is to look for a U-sub function, okay, whose derivative will match, and this is kind of like sometimes it's a little bit tricky, but usually there's a way, okay? Will match up with the other parts of the function, okay? We're going to try to simplify each integrand into something that we have seen before, aka formulas, okay? And already know how to take the integral of using the integral via either the power rule or some of the formulas, okay? Now, let's look at the following example so you can see that it's not that bad, okay? So you have the integral of x squared plus 1 power 5 all of this times 2x dx. Now you're going to tell me, hey, last session what we covered is that we can expand it and then distribute. That's too much, okay? You can have some arithmetic mistakes while you do the expansion of this power 5 and then distribute the 2x. Do you agree with that? So what I see here is something beautiful. What is the inner function, okay, inside the power of 5, okay? So what you have is, I'm going to let, okay, my u be 2x plus 1. Now ask yourself, what is du? Du is 2x dx. Do you agree with that? Now ask yourself, do I have the match of this situation here? And the answer is yes. I'm very happy because I see the exact match here. Do you agree with that? Now, what you're going to do is as the name of this method does, you're going to substitute. So this, you have that u is x squared plus 1, so you have the integral of u power 5, okay, times, okay, you know that du is 2x dx, which is perfect, so you have du. Now ask yourself, can we integrate this u power 5 du? Absolutely. Why? We can use the power rule, okay? Do you agree with that? Now, what are you going to do here? You have that this is going to be u power 6 divided by 6 plus c. But we don't care really about u. We were talking about initially about x's, so you just need to go back to your original variable. So this is going to be equal to what? Parenthesis x squared plus 1, everything to the power of 6 divided by 6 plus c, and that's it. Isn't that beautiful? And that's your integral, okay? That's your indefinite integral. That's why we have the plus c, okay? Isn't that beautiful? For this example, what you have is the integral of x squared parenthesis 2x cubed plus 5 to the power of 4 dx. Now the first question that you are going to ask me, okay, so what are we going to do? So again, you are going to use your new best friend, U-Substitution. So you're going to let the u to be what? Now this is the mystery, right? So what is the most inner equation or expression that you can see here? The most inner expression that you can see here, the parenthesis, is giving you a really good idea of what to use as your u. Here I would do 2x cubed plus 5. As you can see, inside the parenthesis, okay, we have this expression, and all of that is to the power of 4, so it's a very like inner expression. Now ask yourself, what is the differential of this? The differential of 2x cubed is going to be 6x squared, okay, dx, because the derivative of 5 is 0. Okay, now you're going to tell me, okay, I can see the x squared, okay, I can, and the dx is here, okay, so I'm not super happy, because what are we going to do with the 6? Okay, so think about something. What are we going to do with a 6? You divide both sides by 6. Okay, so you have du divided by 6 is going to be equal to, you are going to cancel the 6 by dividing, and you have x squared dx. And now I'm very happy, because what I see here in the original expression is exactly what I have over here. Now you're going to substitute everything. So what do you have here? You have the integral, okay, so you have the x squared and the dx. I'm going to, in my mind, I'm going to pass it here, okay, because you know that the multiplication is commutative. Then you have the u to the power of 4. Then I go ahead and put the x squared dx, which is du divided by 6. Isn't that nice? So you can see that this happens because of the multiplication being commutative. Now, sometimes you're going to see that immediately we used to put the 1 over 6 here in front of the integral of u power 4 du. Okay, that's very normal, and you can do it automatically. Here, since it's the first example that we are doing this way, I'm doing it step by step. Okay, so after that, ask yourself, can we find the integral of u to the power of 4 du? Absolutely, we know that the power rule is there to use it. Okay, so we use the power rule, so you have 1 over 6 u to the power of 5 divided by 5, okay, plus c. Okay, isn't that beautiful? After that, okay, you obviously are going to do the operation here, or honestly you can leave it like 6 times 5. Okay, then you have that the u, we don't want the u, we want my original that it's based on x's. So your u is 2x cubed plus 5 and everything to the power of 5 plus c, and guess what? You are done. Isn't that nice? Okay, so let's do another example, kind of like similar to this one, so you can see if it clicked on you this idea. Okay, so the last example on this page, what we have is the integral of x times root x squared plus 3 dx. Okay, so now again you see that we cannot use any formulas, so you are going to use U-Substitution. Okay, now the mystery here is, what is your u? Okay, so the x is very outside, so it's not a good candidate for the u. So the u is going to be x squared plus 3. And now take the derivative of that u. The derivative of that u is 2x dx. Do you agree with that? Again, I'm very happy with the x and the dx that I have here, but this 2, I don't like it because I don't have it in my original expression. So what are we going to do in this situation that is very similar to the previous example? Now you're going to divide, but by 2. You can do this division as long as you are not using variables, okay? Okay, we can do that because they are constants. With constants or negative, no, well, negatives are constants. We can do this no problem. Okay, so we have this, and now I have the situation, which again I'm very happy. Why? Because you have the x and the dx over here. Now let's substitute everything. I have that it's going to be the integral of the square root of u, okay, because that's my u, okay, and then you have that this is going to be du divided by 2. Okay, so again you are going to do the following: 1 over 2 integral. Remember that the square root, what's going to be the exponent of the square root? Instead of a square root, you have a 1/2 du. Okay, so after that you're like, oh, okay, so it's another powers here, yes. Okay, so you have a polynomial to the power of something, so you have 1/2 u to the power of 1/2 plus 1 is going to be 3/2. Okay, so you divide that by 3/2. Okay, plus c. Okay, after that you are going to, when you do the sandwich rule or whatever multiplication rule you use to simplify this fraction, you have that it's 1 over 3, and then you have that one is going to be what? The u, it's not u, it's what? X squared plus 3 to the power of 3/2 plus c. Okay, whether you change it to a radical form or to fractional exponents is up to you and the instructions. Okay, so here they don't tell you anything, so I'm just going to leave it like that. Okay, but if you want, you can always put it as a radical. Okay, so let's do more examples on the next page. For this example, what we have is the integral of x divided by the square root of 3x squared plus 4 dx. So, as usual, the first thing that we're going to do is figure out what do you think that it's a u. So here, okay, so the most like inside stuff, I'm going to let my u to be the 3x squared plus 4. So what you see here, you take the derivative of this polynomial, okay, and that's going to be 6x dx. Do you agree with that? Now you're very happy here, okay, because you can see the x and the dx, but the 6 is not there. So what are we going to do? Like in the previous examples, we're going to divide both sides by 6. So you have this, and this is exactly what we have here and here. Do you agree with that? Now please remember that u is going to be equal to 3x squared plus 4. So let's replace all the stuff here. So what we have is the integral, okay, of what's that? That's going to be 1 over, okay, and you have the square root of u, okay, and then instead of x dx, what do you have? You have du over 6. Do you agree with that? Now you can rearrange, and you can rearrange the square root as a fractional exponent. So you have 1 over 6 integral, and then you have u to the power of negative 1/2 du. Isn't that look very familiar and very nice? Now we use the power rule. So what do you have here? What we have here is that this integral is 1 over 6 u to the power of negative 1/2 plus 1 is going to be 1/2 divided by 1/2. Okay, then you have your beautiful plus c. Okay, and technically speaking, let's just clean it up. Okay, so you have 2 over 6, which is 1/3. Okay, so then you have the u to the power of 1/2 plus c. And then, as usual, we go back to our x's, our original variable. So you have 1/3, and then you have that it's going to be what? 3x squared plus 4 to the power of 1/2 plus c. I know that some of you prefer to have it in radical form. You can leave it like that if they don't tell you anything, or you can always use your radicals, right? Plus c. Please remember that the radical does not affect the c in this equation, okay? So it's only like that, okay? Hopefully that one makes sense. Okay, so the next one. What's another way that we can apply U-substitution? So let's read this one. Integral of cosine of 3x dx. So here what you have is the most inside thing is going to be the 3x. So you have let u be equal to 3x. Okay, so the derivative of that, it's simpler. So you have that du is going to be equal to 3 dx. You don't see the 3, okay, so what you're going to do, like the previous one, okay, so you have that divide by 3, okay, so you have this one, okay, that it's exactly what we have here, okay, so what do you have here? You have that it's going to be the integral of cosine of u, okay, and it's going to be du divided by 3, okay. If you want to rearrange, you have 1 over 3 integral cosine u du, and that's exactly the formula, okay, that we covered before. So you can see that this is going to be what? 1/3, and then you know that the integral of cosine of u is just sine of u, okay, plus c. You don't want the u, we want the x's, so 1/3, and then you have that it's going to be sine of 3x plus c, and you're done integrating. Isn't that beautiful? Okay, so you can see that it's not that bad. Could you skip a lot of steps here? Absolutely. The more you integrate, the more use you are going to get, and the least steps you are going to need. Okay, so feel free to do that if you feel comfortable skipping some steps there. Okay, don't forget about the c, but skipping steps, no worries. Okay, so this one, you're going to tell me, well, there's a lot of information here. Let's read it. Integral. So you have the sine cubed of x cosine x dx. Now you're going to tell me, how can we decide which one we're going to pick as my u? Well, the one that has the most complication is the sine. Why? Because the sine is inside power of 3. Okay, so technically what you have, okay, so you can see it if you forgot the notation from pre-calculus, this is what you have. Okay, so this is the one that is the most inside. Okay, so what I'm going to do for this problem is I'm going to let my u be equal to sine of x. Okay, so from that you know that the derivative of sine of x is going to be cosine x, and don't forget the dx, which is beautiful. Why? Because you have the cosine and the dx, so we are happy people here. Okay, Why? Because it's exactly as we want. Okay, so what do you have here? You have that this is going to be equal to the integral of u cubed, okay, and then it's going to be du. What are you going to do here? Again, just use the power rule, okay? So you have u power 4 divided by 4 plus c. Go back to your x values. In this case, you are going to have that it's going to be sine x power 4 divided by 4 plus c, and we're done. Isn't that nice? So it looked very complicated, but look at this. Simple, right? Okay, now you're going to tell me, well, what happens if it gets a little bit more complicated like this? Okay, true. Okay, it's similar. Okay, I'm going to put it strategically there. It's similar, but it's not exactly the same. This one has a bigger complication. You have the 5x. So what I'm going to do here, I'm also going to let my u to be the sine, okay, of 5x. Okay, now here the derivative is not as simple as this one. Similar, but not exactly the same. Why? Because you have the chain rule. Okay, you have that the derivative here is going to be cosine of 5x. Okay, and all of this times what? 5, okay, dx, which I don't have, right? But you know better, okay, because we have done, we have dealt with the constants, okay, in the previous example. So you have that it's going to be du divided by 5 is going to be equal to this cosine of 5x dx, which is great. I'm happy again. Why? You see the cosine of 5x dx there. Okay, so what are we going to do here? Replace it. You know that it's going to be the integral of u to the power of what's that? 3. Okay, and then you have that your cosine 5x dx is equal to du divided by 5. Okay, then you have your 1 over 5 here. You apply the power rule, so u power 4 divided by 4 plus c. Okay, please remember these are multiplying each other. Okay. After that, what are we going to do? You have 1 over 20, and then we have that it's going to be sine of, in this case, 5x all to the power of 4 plus c, and that's what we have for this problem. Do you see it? So it's not that bad, okay? So let's move on to more examples. Now let's complicate things a little bit more. We have the integral of x cosine power 4 x squared sine of x squared dx. Okay. So what are we going to do? This is a lot again, so you are like, okay, I have power of 4, so most likely your u would be what? Cosine of x squared. Do you see it? Because you can see, you can rearrange. Let me rearrange it. If you don't see it, no worries. Okay, so you can see how to rearrange this monstrosity. Okay, don't forget the x that I have here, x dx. Okay, so you have a situation like this. Do you agree with that? So the one that is the most inside of functions is the cosine of x squared. Okay, so what I'm going to do here is I'm going to let my u to be equal to the cosine of x squared. Okay, now what's the derivative of cosine? You know that it's negative sine of x squared. And chain rule, what do you have for the chain rule? Let me put the parentheses there. 2x dx. Do you agree with that? Because you have the derivative of this one. Okay, so you're going to tell me, hey, I have pseudo this, but I don't have neither the negative nor the 2. True. Okay, so what are we going to do here? Okay, so you're going to pass dividing, okay, the negative 2, okay, which is possible because it's a constant, negative and 2 both. Okay, so and then you have that that's going to be equal to sine of x squared x dx. So please note x dx and the sine of x squared. So I'm very happy. Again, happy face there. Okay, I can see the pieces of the puzzle here, right? Okay, so now what are we going to do? You have that this is going to be equal to the integral of what? U power 4, okay? And then you have du divided by negative 2, okay? So you can see here that it's nice, okay? So you have that this is going to be equal to negative 1/2, apply the power rule, u power 5 divided by 5, this is multiplying each other, plus c. Okay, now what are we going to do? Go back to your x's, right? So negative, okay, and this is going to be 1 over 10 because 2 times 5 is 10. Okay, and then your u, what was your u, is cosine of x squared, okay, power 5. Don't forget that power 5 and plus c, and that's it. Okay, isn't that beautiful? Can I rewrite it like this? Okay, yes, of course you can rewrite it like this. It's the same thing. Okay, it really doesn't matter. This or this, both are correct. Okay, feel free to use either notation of these two. Okay, so Let's move on to another type of questions here. Okay. Here I'm asking to solve the differential equation dy dx is equal to 9x squared divided by the square root of 1 plus x power 3 plus 5x. And you're going to tell me, I forgot what is to find a differential equation. Well, they are telling you, hey, I want you to find my original equation, in this case y, okay, or f of x, okay, whatever you want to call it. Here, I'm not giving you an initial condition, so the best thing that you can get is something plus c, whatever. Okay, so what you're going to do is, you know that y is going to be equal to the integral of all of this monstrosity, right? So it's 9x squared, all of this divided by 1 plus x cubed inside the square root, plus 5x, and all of this dx. Okay, so that's what we have. Okay, that's what we want to do. And you're going to tell me, well, this is not as trivial. Yeah, okay, so you have that this is going to be equal to two beautiful integrals. Okay, integral number one, you have integral of 9x squared divided by the square root of 1 plus x cubed dx, and the second integral is the integral of 5x dx. Okay, so that's what we have here. Okay, so this one, pretty simple, straightforward. Now this one, okay, it's going to be another story. Do you agree with that? So what are we going to do with this one? Let me highlight this one. Okay, so this one. Okay, be careful. Okay, now what you're going to do for the yellow one is you're going to do u equals 1 plus x cubed. Okay, and then you have that the derivative of this one is going to be 3x squared dx. Do you agree with that? Now, as the previous examples, you don't have the 3, so you have du divided by 3 is equal to x squared dx. You're just looking at the yellow one, okay? So we're doing the u substitution only for this one, okay? And I'm going to put here, just for the yellow one. The other one, we leave it like that, okay? So what are we going to do, okay? So what you have is that you have that this is equal, okay? All of this is equal to what? You have the 9, okay? What else do you have here? Okay, you have that it's going to be divided by the square root of u. Do you agree with that? And then you have that it's going to be times the dx, okay, the x squared dx, okay, which we are very happy with it. It's going to be du divided by 3. Do you agree with that? The other one, okay, stays the same. I haven't changed it at all, okay, so stays the same. So here we have the yellow part. So you're happy because you see the light at the end of the tunnel here. Okay, so what do you see here? We see that this is 3. Okay, this is the integral of u to the power of -1/2 du plus this one that we keep it the same. Okay, you can integrate it or not, but I'm keeping it the same so you understand that I'm not doing anything to that one. Okay, so look at the yellow one. Okay, this one easy. Okay, but this one, it becomes as easy as this one. Okay, so what do you have here? You have that that is going to be equal to what? 3. Okay, u to the power of -1/2 plus 1 is 1/2 divided by 1/2, right? Multiplying each other. Okay, then you can integrate the other part, this one, separately with x's, right? So that one is going to be 5x squared divided by 2 plus c. Okay, and that c attacks both terms. Okay, so you have this. Okay, so next you have that this is 6. The u, we know that it's 1 plus x power 3 to the 1/2. Okay. Plus 5/2 x squared plus c, and guess what? We're technically done. Okay. As you can imagine, I know that some of you are picky with the 1/2 and you prefer the radical form. Okay, so therefore, what do you have? Thus, y is going to be equal to 6 square root of 1 plus x cubed. Okay, and then you have plus 5 over 2 x squared plus c, and that's as much as we can do in this situation for our differential equation. Why we cannot find c? Because they are not giving you an initial condition. Okay, so that's for this example. If you have any questions, please remember to write them in the comments, and I hope that you find this video helpful. Bye.